Let us quickly look at ammonium salts. What are ammonium salts? The meaning, the preparation, properties, and test for ammonium salt. Now, meaning, what are ammonium salts? Ammonium salts are electrovalent compounds containing ammonium ion. That is, electrovalent compounds containing ammonium ion. That is NH4+. Any electrovalent compound containing ammonium ion is an ammonium salt. Let me bring your mind back to how salts are formed by neutralization. This is a general representation of acid. This is a general representation of a base, because base, we use OH to identify a base. Then here, this is acid radical A. This A represents acid radical. This is hydrogen, removable hydrogen ion. Here, this is a metal. This is acid radical. So when acid reacts with a base, a salt is formed. The salt is formed from the metallic atom from the base and acid radical from the acid. So we have Ma, which is salt. The OH will react with H from acid to form water. This is neutralization. Therefore, a salt is an electrovalent compound containing a positively charged metallic part or ammonium part and a negatively charged acid radical. Examples of ammonium salts where ammonium ion is representing the positively charged part of the salt are, we have ammonium chloride. Chloride is the acid radical. We also have ammonium sulfate. Ammonium sulfate. This ammonium chloride would have been formed by reaction between hydrochloric acid and aqueous ammonia, which is ammonium ion plus hydroxide ion, aqueous ammonia. When these two react, ammonium ion will react with chloride here to form ammonium chloride. OH minus will react with H to form water. So hydrochloric acid reacts with aqueous ammonia to form this salt. Here, this salt may have been formed from tetraoxosulfate 6 acid reacting with aqueous ammonia. That is ammonium ion plus hydroxide ion. To form this, combining with this, and we have ammonium sulfate plus this, combining with this to form water. To form water. Okay, let me just forget about balancing the equation. So these are examples of ammonium salts where the positively charged part of the salt is ammonium ion. Preparation. There are two ways you can prepare ammonium salt. Number one is by dissolving ammonia gas in a choice acid, any acid you want. Number two is by reacting aqueous ammonia. That is ammonia dissolved in water already with a choice acid. Okay, let's take the first method. This is ammonia gas. Let's take any acid like tetraoxosulfate 6 acid, aqueous. So when we dissolve ammonia inside this ammonia will react with one of the protons here to form ammonium ion plus. Then SO42 minus will combine with it to form ammonium sulfate. This is the salt. This is the salt formed. So to balance the equation, nitrogen is 2 here, so we'll write 2 here. Hydrogen is 6, 8. and it's 8 here. Everything is balanced. So this is the first way of producing ammonium sulfate with sulfuric acid. You can also produce another ammonium salt using another acid. Let's use hydrochloric acid. You know, when we do this, we have ammonium chloride salt straight. That is number one. Another method of producing ammonium salt is by reacting aqueous ammonia with choice acid. This is number one. Number two, aqueous ammonia is when ammonia gas dissolves in water liquid, we will get ammonium hydroxide. This is called aqueous ammonia. So this aqueous ammonia now, NH4OH, dissolved in a choice acid. Let's use HCl, aqueous, this aqueous too. So when they dissolve, remember NH4 plus is here. So it will attack the chloride part of the acid, and we have NH4Cl. This is a salt. Remaining OH and H, which will form water. So that is the second method of producing or preparing ammonium salt. The next is properties. The properties. Number one, all common ammonium salts are white, crystalline solids. They are white, crystalline solids. Number two, they are highly soluble, just like the table salt, your cooking salt, sodium chloride. They are highly soluble in water. In fact, they resemble their group 1A metallic salts, like sodium chloride, potassium chloride. They are white crystalline solids, and they are highly soluble in water. They readily ionize in water. Therefore, they are strong electrolytes. Example, ammonium chloride. It readily dissolves in water and ionizes completely into ammonium ion and chloride ion. Because of this behavior, ammonium chloride and other ammonium salts are strong electrolytes. They are strong electrolytes, meaning that if ammonium chloride is dissolved in water and the electricity is connected, it will quickly ionize. In fact, once it is dissolved in water, it will quickly ionize into ammonium ion and chloride ion, positively charged and negatively charged ions, respectively. And once electricity is connected, this cation will migrate to the cathode, and anion here will migrate to the anode. That is the meaning of being strong electrolytes. Number four, all decompose on heating. All kinds of ammonium salts decompose on heating. Some sublime. Example, ammonium chloride sublimes on heating to form ammonia and hydrogen chloride. So when you heat an ammonium salt, it will decompose on heating. It will break into its respective ions on heating. It will break into its respective components. It may not likely be ions on heating. For instance, let's use this ammonium sulfate. Ammonium sulfate. Remember that if you look at this, you will see tetraoxosulfuric acid with ammonia, because that is how ammonium salts are formed. Ammonia combining with an acid. Therefore, when you now heat this, when you heat it, it will quickly decompose into its parent ammonia gas and tetraoxosulfuric acid that it was formed from. So that is it. You balance the equation. Yes, I think the equation is balanced now. If you heat ammonium chloride, if you heat it, it will sublime instead. Sublimation means it will turn directly to, this is solid now, it will turn directly to gas without melting. That is the meaning of sublimation. The gases are ammonia gas and hydrogen chloride, hydrogen chloride gas. Not only turning into these gases on cooling will recombine to form back this ammonium chloride solid. That is the meaning of sublimation. Number 5 is reaction with a base. So all ammonium salts reacts with a base when heated to liberate ammonia gas. For instance, now let's take ammonium sulfate plus a base, hydroxide ion, then plus heat. You will see that you will get ammonia gas. You will get ammonia gas. How? The hydroxyl ion here, this thing is going to break into sulfuric acid and ammonia gas. So this is the ammonia gas gone, remaining sulfuric acid. This sulfuric acid will be neutralized by this base to form water, then remaining the acid radical, to be attacked by the metallic part of this base. If it is sodium, you have sodium sulfate, and so on and so forth. Finally, how do we test for the presence of ammonium salt? It is very simple. It's a laboratory procedure you can easily do. Test, observation, and inference. Okay, an unknown salt A. This unknown salt is suspected to be an ammonium salt. So, you add a base. You add a base like sodium hydroxide plus heat. Once you heat this, what you are going to observe is a choking, a colorless gas with irritating or characteristic smell. So once you see this kind of gas evolving from the reaction mixture, the inference is that the gas is ammonia. Ammonia. From where? Ammonium ion. And remember, the unknown salt will have contained ammonium ion for it to liberate ammonia. Therefore, the salt is an ammonium salt. So this is the simple laboratory test. When you add an unknown salt A to a base, or you drop a base into an unknown salt A and heat, a colorless gas with irritating or characteristic smell will be evolved. That gas is ammonia. You can further test the gas with hydrogen chloride, which fumes in the presence of hydrogen chloride gas. Yes, that is a test for ammonia gas. If it fumes in the presence of hydrogen chloride gas, then you confirm that the gas is ammonia from ammonium salt. Therefore, if there is ammonium salt is in this unknown salt, it now means that the unknown salt is ammonium salt.